All right, Jim. This is Jim's bio here. So after a 32-year career in aerospace software engineering, Jim Alstad resigned to take a job as a teaching assistant at USC under Dr. Bain, which resulted in his receiving a PhD for his thesis on Cosismo 3.0. He then retired to spend some time on causal analysis, Cosismo, playing bridge, and programming for fun. And what he didn't mention here is that we both co-TA'd or teacher assisted under Dr. Bain for quite a few years, and we both are working on the causal analysis work that he's been doing in his retirement. So I look forward to seeing what your presentation is, Jim.
Okay, as soon as I can get it actually on the screen. Yeah. PowerPoint is not cooperating. And PowerPoint is still not cooperating. Let me try something else here. There, how's that?
You're not sharing right now.
Oh, other than that, though, how is it? I just thought of a useful question.
Oh, your video and audio is good.
Okay, but
Hey, it's loading. All right, I see PowerPoint. Yep, now it's in slideshow view. Perfect.
okay, thank you. Well, this was originally scheduled to be at 3:15 tomorrow. Excuse me, well, there's the last presentation tomorrow, following a presentation by jointly between Anandi and me and Windsor and Mike Conrad. And to some extent, this was going to, that previous presentation was going to set up this one. But I'll have to do a little legwork here. But first, it's actually very good that I was changed to follow Alan's presentation. I have some things in common with Alan, in addition to 1, 2, 3 infinity. One is that I lived in Milwaukee for 5 years. Another is that I actually grew up in Madison, which is 80 miles west of Milwaukee, and the weather is worse in Madison. And I want you folks to know that those pictures that Alan showed of the weather were not taken in Milwaukee. They were taken in Madison. So just to show the relationship between Alan and me. All right, so these 3 other people that are credited, and I will be giving the talk tomorrow about causal analysis. I'm going to talk a little about causal graphs and scientific inquiry into some phenomena, causal analysis versus a scientific method in conclusion. Now, to set up what you need to know about that other talk, part of it is involved with the analysis of the Kokomo 2 calibration data. And if you want to think about that data a little bit, the columns are the various parameters of Kokomo 2. And the rows are projects. So the data for each individual project is one row in that rectangular array. And similarly for my Cosismo data. And the talk is going to, that other talk is going to cover causal graphs. And what you need to know for purposes of today's talk is that there are causal graphs, and some of them, some of the representation uses circles, and a circle in a causal graph is some phenomenon under study. Phenomenon has to be quantifiable, either numeric or a choice among a finite set of possibilities, and has to be consistently measured. So a solid circle is something you can observe. A dashed circle is something that's not observable. And on edges here, if there's an edge, a directed edge from circle A to circle B, phenomenon A is an immediate cause of phenomenon B. And for purposes of my talk, we're going to say maybe it's a hypothesis we're trying to find out, that is, or we're hypothesizing that A causes B, not necessarily that it's been actually verified. Now, on the other hand, if there's no arrow, then phenomenon A has no immediate causal relationship to phenomenon B. In a causal graph in general, the phenomenon may have no immediate causes, one immediate cause, and more than one immediate cause. And the notion of direct causality that we use is that A is an immediate cause of B if some change in the value of A makes the value of B change, at least under some circumstances. Okay. All right, so now let's do a little scientific inquiry here. So somebody once noticed that there's actually a strong correlation between the level of ice cream sales and the number of shark attacks. All right, so why don't we start hypothesizing what might be going on? So one theory is that ice cream sales might be causing shark attacks. Or this is a possible theory. Ice cream sales cause shark attacks. So we limit ice cream sales and expecting shark attacks to go down. Well, maybe we have a different theory, that shark attacks cause ice cream sales. So we would take direct measures to reduce shark attacks and we expect ice cream sales to go down. Well, perhaps if you think about this a little, you might think that there's actually another theory that, or you can think about first the fact that there's a problem here, that correlation is not causation. In order to find out where actual causes are, we need an influence from the third phenomenon to determine causation. So if you start thinking about possible third phenomena, you might think about high temperatures. You might think that high temperatures could cause both increased ice cream sales and increased shark attacks. So that's a reasonable scientific theory. Another scientific theory is that it's actually the shark god that's doing this. The shark god is displeased with too much consumption of sugar, and the shark god retaliates and causes more shark attacks. We need to say that actually people in general don't understand the shark god's feelings. They're not knowable, but there are shark shamans around that interpret the shark god's feelings. And they can reasonably reliably relate those feelings. And so we could actually, presumably test whether it's the shark god that's interpreting ice cream sales and increasing shark attacks. Well, one of the issues, so we have two different scientific theories here. Scientific number 2 with the high temperature, and scientific theory number 3 with the shark god's feelings. Well, one of the things we really need is an ontology. An ontology is a description of what kinds of things, what kinds of phenomena there are in the world. And we get different results in our science, depending on whether there are thermometers or shark shamans in the world. Given that we know the ontology, causal analysis can help by analyzing scientific theories number 2 and 3. A causal analysis can identify immediate causes, which means that a causal relationship can be identified even though a mechanism is unknown. So that's pretty interesting. You can identify causality without knowing the mechanism. However, as was just observed, the causal analysis is limited by its ontology. So that's one point that I want to make. I will say that if you hypothesize that both things might exist, then given sufficient data, causal analysis could discriminate. You could tell whether the temperature phenomenon or the shark god's feelings phenomenon was causal. So I have been or had been for decades a believer in the scientific method. And here's a brief definition. The scientist forms a hypothesis predicting a new causal effect. The scientist performs an experiment gathering relevant data. The scientist performs a causal analysis on the data, confirming or disconfirming the hypothesis. And so that would be the scientific method as I learned in high school. However, it's possible for a scientist to simply gather data and then perform a causal analysis looking for hypotheses. When I was introduced to causal analysis, I disliked this approach because it flouted the scientific method. Since then, however, I've given up my dislike because I discovered that many scientific fields and scientists use the data-first approach as part of their normal procedure. So I guess if many scientists will bypass the scientific method, I will too. All right, so here are a couple of conclusions. So 2 ways among several that science can advance are finding new phenomena, new circles to put into the graph, and finding new causes among phenomena. So causal analysis can help with the first one, but it can't help with the second. And that's what this second bullet says here. So if you're doing causal analysis, the ontology should be acknowledged and when appropriate, justified. Oh, and I have an annotated bibliography here, which is somewhat idiosyncratic about causality and causal analysis. Judea Pearl's book is kind of foundational. It's this textbook on causal analysis, causality, models, reasoning, and inference. There's a primer on causal analysis, causal inference and statistics, a primer. And this is a good introduction to the how and why of causal analysis. So I went looking into Wikipedia entry on causality, and I got some more things. One is a chapter of a book that analyzes the causal nature of karma. So depending on your spiritual beliefs, you might find this one to be interesting. Another is a book that many people in my generation are familiar with, Catch-22. Catch-22 is a rule that appears to give you a choice, but in fact, there's only one result possible. That regardless of what you think the cause is, you're getting the same result. And while I was actually working on this presentation, I had my radio on, as I frequently do. And there's an episode of the radio series called Radio Lab. And this particular episode I listened to was a critical history of the United States Supreme Court case, Daubert versus Merrill Dow. And that case decided what scientific evidence of causality is allowed into US courts. So I felt I had to add this to my bibliography. That's my presentation. Are there any questions? And at the moment, I do not have the chat in front of me.
Well, currently there are no questions in the chat, but if any participants have questions, please feel free to come off mute and ask your questions.
Oh, Jim, it's Brad.
Uh-huh.
It seems to me that in the ice cream and shark relationship, that when it's hot outside, you're at the beach, people buy ice creams, people swim, and they are more vulnerable to shark attacks. If it's cold outside, people at the beach, they're not going to buy as much ice cream, and therefore not perhaps also not go into the water because it's cold, and therefore be less vulnerable to shark attacks. Even though there's a kind of a confounding reason of why ice cream sales and shark attacks have a correlation. In the data first approach that you talked about when you were discussing scientific method, I've seen in the cost world two approaches to software cost. One is what I think is the Barry Boehm approach, is you reason about a cost model and the drivers that influence the prediction of that model, and then you try to build the model and validate it with data. The other one, and then I think this is more the Vic Vasili school of thought, is let's see what the data tells us. We're just going to analyze the data for every different kind of relationship we can see, and let's see if those relationships, if there's any strong relationships in that data. And the second one, the data first, seems to me to be more susceptible to having an unknown factor, a confounding factor that, yeah, these two things may correlate in the data, but there's something else that actually drives that relationship. There's a cause, another kind of cause. It could be the shark god, it could be the temperature. Is that kind of what when you said data first approach, I mean, do you feel like the data first approach, instead of doing the scientific method, is one that's vulnerable to not identifying third factors or fourth factors, that other factors that might be influencing correlations? Is that what do you think about that idea about the data first approach? Is it?
I have a pragmatic approach, and I think you should do anything that works. So as you characterized Professor Vasili's approach, he would analyze a large amount of data and look for causes. And then once he has a causal hypothesis, he would then have to test it on some other data, in the real world. Barry's approach, as I happen to know from having this book right next to me, is to survey experts and then see if the experts, and to survey experts and come up with a model, and then try to validate the model. And either of them could work. I would not prefer one to the other as long as there are results.
Now, I'm not trying to jump ahead. This may be in the next presentation with the SCI group, evaluating software and system engineering data with causal inference algorithms. But I think you guys did look at Kokomo and all of its factors. I mean, there's so many cost drivers. It would have been wonderful if we could have reduced that set. But did you guys find anything interesting in examining the Kokomo data?
Oh, Brad, you're going to have to wait till 3:15.
Okay.
Simple answer is yes, so don't skip it.
Little teaser. Okay.
Any other questions? Okay, back to you, Nandi.
Thank you, Jim. And just so that you don't forget to come to our presentation, it's later today, not tomorrow.
Yeah.
And for everyone else also, we have a full day today. There will be no forum tomorrow, but for those of you that are coming, we have the dinner tomorrow night. All right, so we are off to lunch. We are